I think I'll tell you some general information while it's still in my head. It'll take me a few days, definitely two, to check your tests and put together your first report. So somewhere middle of the week, Wednesday, Thursday is my prediction on when you'll get your report. So that is that. So what we're going to look at today is alternating series and absolute convergence, which is basically just continuation of what we did on Friday. So let's pick a guy and just take you through the alternating series part, because for the most part we have already covered what you need to know in alternating series. I'm just trying to find a good one. And this one I'll do. So it's not any particular question. Right, suppose we look at this alternating series. I know it's an alternating series because of this feature, right? It's pretty easy to tell an alternating series. And the question is going to be prove that it converges, which it does. And then we're going to do some questions involving estimating what the sum is, right? So what would that add up to? Or at least an estimate of what it would add up to. So EN is basically that guy. I think that guy's quite a nice way of looking at it, because there are two things we need to prove that this series actually converges. Don't we have to prove that the limit is 0? And by writing it that way, I think it's easy to prove that this guy is 0, because can't I just do brute force? Right. You comfortable with that? The first part of proving that an alternating series converges, or for that matter diverges as well. You show me what its limit is. For a lot of questions, don't they tend to be just brute force? Right? Occasionally, a really awkward one you might do a L'Hopital occasionally, right? But most of the time, it's brute force. And the second thing is, you have to prove it's decreasing. And I'm going to write. Whoa! I am going to. Excuse me. Get somebody to admit. There we go. And I was saying, I'm going to have to prove that this decreases. And I think writing it in this form is probably a little bit easier. So if you differentiate 2e to the negative n, you get negative 2e to the negative n, which I'm now going to write style points. Now, to prove something's decreasing, you really just take the top, which is negative 2, and that's always negative. And then you look at the denominator. Well, as long as n is 1, 2, 3, 4, and so on, the bottom is a positive thing. And a negative on the top divided by a positive thing on the bottom gives you a negative answer. And negative answers are less than 0. So we have shown that the series is decreasing. It's decreasing because I have proved its derivative is negative. So far, so good. Right. That's prove it's convergent. Done. Pretty straightforward. Boom, boom, done. So let's suppose that was question A, right? Prove that it's convergent. So we've done that. And now we're going to look at what does this sum add up to? What does this series add up to? And so we're going to do it by estimating it. So I'm going to estimate what this is. By calculating S4. So they're telling us to use S4, we'll use it. Now S4, well, if you plug in 1, you get positive. So it's that guy, take away that guy, add that guy, and take away that guy. Are we comfortable about what I just did there to evaluate S4? Plugged in 1, got this one, plugged in 2, got this one, plugged in 3, got this one, and finally plugged in 4. And at this point, we could just do it on the calculator. So 2 times e to the power of negative 1, subtract 2 times, God my eyesight, e to the power of negative 2, add again, 2 times e to the power of negative 3, and then finally take away 2 times e to the power of negative 4, and we get 0.52803 and some stuff. Let's say they wanted the answer to 5 decimal places, so that's what we would do. So if you went and said to me, estimate what that adds up to, there's your estimate. But how good is that? I mean, is it really 0.52? Or it might be as big as 0.92, right? It might be as small as 0.32, but I mean, don't we really need to know plus or minus, right? So if you wanted to estimate this, right, by calculating this, won't we get a guy called R4? R4 is basically a measure of the worst case scenario. What's the biggest error you could get? In an alternating series, isn't R4 the value of A5, right? The next number that you would have used, but never got to. And A5 in this case, well, I don't even care about -1 to the n plus 1 to be strictly speaking, but I'll put it in now. So it's 5 plus 1 times 2 times e to the -5, because that's the bit that everything important is. That's just going to be a plus or minus. So I'm going to go 2 times e to the power of -5, and the answer I get this time is 0.1347. So if we wanted to say what this was equal to, we'll call it S, it's equal to 0.52803, give or take 0.130. There's a 0 there. 0.1347. And if I was being a little bit, more rounding off, can you see that the answer would roughly be somewhere between 0.52 and 0.54? Isn't that much more helpful? That I know this series converges, and I know it converges to something between 0.52 and 0.54. So far, so good. And that might be question B. And sometimes you get question C. How many terms to get an answer correct to 4 decimal places? So, well, I need to find S of 100 to get 4 decimal place accuracy, right? Or S20, or maybe only S10, right? Now, if you want to do that, what you're really looking for is the Rn, the remainder, to be good to 4 decimal places. The answer isn't 0001. When you do 4 decimal places, isn't it 4 zeros and a 5? Remember that? Because if you round something off to 4 decimal places, you actually have a 5th decimal place rounds up, or the 5th decimal place rounds it down. So that's what that's all about. And ARN is in fact AN plus 1 then, great. And an plus 1, forget about that bit, is 2e to the negative n plus 1 equals this guy. And I'm going to rewrite that as 2 over e to the n plus 1 equals that guy. Now, if you can, you should try and solve these questions exactly. And this one is doable, so I'm going to do that. Any suggestions for what I should do next? Because there are a couple of ways of approaching this. I'm trying to find it.
You could find the reciprocal of both sides.
All right, so that would be my approach. You could also cross multiply if you felt like it. That would also work. So if I just take 1 and divide it by 0.1, 2, 3, 4 zeros and a 5, you get a really nice number. You get 20,000. Would you agree you then multiply both sides by 2 to get 40,000? So far, so good. Now tell me what to do next then.
Natural logarithm.
Okay. And then couldn't you just subtract 1 from that? And there's going to be a little rounding off issue at the end, but we're going to do that. So it's a natural log of 40,000. And then take away 1. And the answer I get is 9.59 and 7, whatever. But how many terms does that become?
10.
What do we, 10. So we are going, you would need to do 10 terms. So if you wanted to know what that series added up to, correct to, in this case, 4 decimal places, all you would need to do is calculate S10 and round it off to 4 decimal places, and that would be the correct answer to 4 decimal places. See how it works? Now, if you want 100 decimal places, you could do it, can't you? I mean, at least you could find out how many terms you would need, but wouldn't you get a computer to figure it out, to add it up for you? Now, sometimes, it didn't happen here, but I should do it as an example. Sometimes the equation that you need to solve, you cannot do it algebraically, right? Just ain't going to happen, right? So let's pretend that we had the same problem with this one. How could I still solve it? Well, you can do it on your calculator. It's messy and you have to do a fair bit of tweaking, but you should be able to do it. So you go into y equals, clear that guy out, and you go 2 divided by e to the power of n plus 1. Well, I'm going to call it x plus 1. So far, so good. Then you do this guy as y2, 0.00005. So far, so good. Then go to your window and start at 1, because won't you start with x is 1 the first term, right? Or n is 1. And then you might have to make a prediction. So I'm going to go, and I know the answer is 10, but let's say 15, because I don't know the answer. So I put 15 in. And then you do zoom 0 and zoom to fit. Right? That's what that guy looks like. And did you see the other line appeared very low? Would you agree that it's going to cross this curved line somewhere round about where my pen is? Right. Now, all I need to do then is I go back to here, and do you see the y min and the y max, guys? If you scroll to the end of this guy, you will find there's an e there. Do you see it? So that means this number is really small. So I'm just going to go up here, and I'm going to pick 12. And I know that it's bigger than 5. And so I'm just reducing my window a little bit, and then I'm going to do zoom to fit. Still too low. I'm going to go here and make that 9 and zoom to fit. And I think this one will probably do it. There. You see, if you play about with the windows, you know, I started with 1 to 15, and then I said, yeah, it's probably 5 to 13, right? And I'll do 6 to 10 or 11, right? And when you get to it, isn't that the guy we're looking for? So all you then do is go second calc, choose intersect, first curve, hit enter, second curve, hit enter, guess, hit enter, and there's your answer. Do you see the 9.59? There. So if you get a really ugly, can you imagine it was, I don't know, x sine x over x cubed, right? And it ended up converging, right? You don't want to try and solve that algebraically. Can you just plug it into here and find out when the expression passes through the number, whatever you want? That's pretty much it. Is there anything that I've not covered you feel you want me to do on alternating series before we now move on to the second half, which is called absolute convergence? You feel good? That one question kind of had everything in it, right? So if you kind of use that as a template for how to do alternating series, I think you'd be good. Better not throw other people ask questions. So next fellow we're going to talk about is called absolute convergence. Now, here is the definition of what absolute convergence is. A series is said to be absolutely convergent if sigma n equals 1 to infinity of an, the original sequence, and n equals 1 to infinity of its absolute values are both convergent. So a series is said to be absolutely convergent if the original series converges, obviously, but if this one converges. Now, can you imagine an alternating series? That's one of the places this would be the best to use. Doesn't an alternating series have pluses and minuses? But can you imagine a situation where the alternating series converges, but if you made everybody positive and added them, that new series diverges? Can you imagine that could happen? So just because this converges does not guarantee that this one does. But if this one does, we have a thing called absolutely convergent. Now, a series is said to be conditionally convergent if that guy converges, but when you take the absolute value of it, it diverges. And lastly, a series is divergent if that diverges. Well, you might think, Well, is there a situation where this series diverges, but when you make everybody positive, right, if you take the absolute value of them, that might converge? And the answer is no, that can never happen. If a series, right, an untouched, you didn't do anything to it, diverges, it diverges. We don't even say that it absolutely diverges. We just say it diverges. So diverges is still diverges. There's only one version of it. It don't work. But there's now two versions of convergent. You are conditionally convergent or you are absolutely convergent. And there is a difference between these two. If it's absolutely convergent, that's like the Rolls Royce of series. They are really cool series. You can do anything you like to them and they behave really well mathematically. Conditional converging series are like you bought a lemon. It might work. It'll probably get you to your mum's house, but it might break down. There are some things that can happen to a conditionally convergent series which are totally weird and not obvious. Your intuition will fail you. You will think nothing could be wrong, right? It should do this. And you'll be amazed at what it sometimes doesn't do. So let me show you a conditionally convergent series. Let's show you one of the limits. Take that guy. Oh, actually, make a +1 just for fun. That guy is 1, take away a half, plus a third, take away a quarter, forever. Basically, isn't it an alternating series that came from a harmonic series, right? Do I need to prove that, or are you quite comfortable that that converges? Can you just look at it and say that that's going to converge? So this one converges. And if you want to prove it, you can do it by using the alternating series test. Doesn't it have a limit of 0 and isn't it decreasing, right? Pretty easy to prove. Now, if you want to make everybody here by sticking an absolute value around it, doesn't this guy turn into this one? Do you recognize sigma 1 over n? It's called the harmonic series. Remember that guy? Isn't it a p series as well? And isn't its p-value 1? And what do you know about p series that have a p-value that are less than or equal to 1, as this one is? What do you know? It diverges. Do you see that we've got a series then that is called conditionally convergent? So you might think, big deal, some series converge when you leave them alone, but when you make everybody positive, you end up with a divergent series. And can you see that that's probably going to be alternating series for the most part? Can you imagine mostly alternating series? This would be a situation that might have, right? And you might think, well, big deal, what's the problem? Well, here's a problem. And this is one that they've discovered quite early on. If you take any conditionally convergent series, so we'll just call it conditionally convergent series. If you rearrange the order in which you calculate the series, you get different answers. What? How could that happen? But it does. If you take this conditionally convergent series and you rearrange the order in which you add and subtract them, you get different answers depending on how you rearrange them. Give you an example. If you took this guy and you decided to take all the plus guys, which are these guys, and then you took all the negative guys, which are these guys, and you took this lot and you subtracted that lot, would you agree it's the same thing as the original question? Right? 1, a third, a fifth, a seventh. Take away the half, the quarter, the sixth, the eighth. Would you agree it's the same calculation? Right? Do you recognize a half, a quarter, a sixth, and an eighth? Isn't that half of a harmonic? What do you get here? You get infinity, take away infinity. Would you agree infinity, take away infinity is not a good place to be? That particular combination actually, God, what does that one go to? I think that one actually goes to negative infinity. Don't quote me on that, because it could be plus. I can't remember which. Now, I can rearrange that all sorts of ways. Couldn't I pull out some terms that are in the 3 times table, right? The third, the sixth, the ninth, and then all the other stuff in the second group. I could make that add up to 2. I could make it add up to 52. I could make it add up to any number I like, just by rearranging how you add them up. In other words, have 2 infinite groups, one group and then the other group. Together, they're still that guy. But by choosing them in certain ways, you can get different answers. And what that tells us is that if you are ever doing a calculation with a conditionally convergent series, you should have red lights flashing and danger, Will Robinson, danger, Will Robinson. Because if you just happened, or the computer program that you told it to add it, decided to do it in a particular order, couldn't you get a different answer than if something did a different way of the same calculation? Really dangerous. We don't like conditionally convergent series because of this horrible property that if you rearrange the order in which you do the calculations, you will get different answers. In fact, sometimes you can get answers that are infinite. And that is very, that's not intuitive. Wouldn't you think, well, okay, well, if I add it in this order, it's going to work. Actually, that adds up to log 2 if you're interested. Right. Yeah, but if I just decide to switch places, to do the half before the 1, to do the quarter before the third, right? Imagine I did that. You might think, well, that shouldn't cause any damage, right? It's the same terms. The answer is it adds up to something totally different than it would the first way, which is not obvious, but still true. There, does that not hurt your brain? That a series can add up to different things depending on how you decide to add them together. That is weird. Which is why we like absolutely convergent, because absolutely convergent series, it don't matter how you add them up. It's always the same answer, right? You can shuffle them about, you can do them big to small, you can take the first half and then add the second half, do anything you could possibly think, and the answer is still the same. Now, isn't that much more stable? So if I do anything that involves these kind of series, I'm very comfortable that I'll be safe and no damage could be done. On this kind of series, shouldn't I be really worried that I might come up with a number like, I think it's this, but if somehow it's, it got mucked about with in the calculations, we would be in trouble. So let's see if I can find one. Okay. Let's find out if this series is absolutely convergent, AC, conditionally convergent, CC, or it just diverges. Gut feeling. Any ideas what it might be?
Conditionally.
Yes, it's going to be conditional. So let's prove it. It's an alternating series, right? AN is essentially that guy. The limit as n tends to infinity of this guy, if you do brute force on it, is 0, which it should be. If I take my function, which is this guy, call it that, if I differentiate it, I get -1/2, reduce the power by 1, and then make it look pretty by doing that. And I'll give the -1 to the top, so that's negative. 2 times the cube root is positive. There's the classic, the whole thing is negative, so it's 0, and so it's decreasing. So I know that series converges. And I should check that one first, shouldn't I? Because if it diverges, isn't that the answer? There's only one version of diverge, right? Now, that is the original series, and we know that converges. If you want to see what its absolute value one looks like, don't you basically just take away the -1 fella, right? That's a 1 there. Right. Let's check this one. Do you recognize that that guy is a P series? And that the P value is 1/2? And isn't that less than or equal to 1? So it diverges. And if this converges, but the positive values, right, the absolute value values, diverges, then that means that this is a conditionally convergent series. Are we cool with that process of how you find out if something is conditionally or absolute? If I'd done this and this had converged as well, since the original converges and the one where everybody is positive converges, wouldn't this now be called an absolutely convergent series? Are we good? Not sure. I'm seeing some unhappy faces. Right, here goes. This one is question 14. Let's try another one. We're going to be looking at that fellow there. I'm going to save some time here. You're not allowed to, but I am. Can I tell you that that's an alternating series and it converges? Can you kind of tell by looking that it is, right? So I know that this converges. So let's just focus on what would happen if you took the absolute value of that. Well, all that does is do that. Are you comfortable about the absolute value? Now, this fella here is not an alternating series. And that +6 stops it from being a P series. But I can still find out if it converges. I just have to use something that we've used earlier on. Wouldn't this be a limit comparison test? Can you see that to check if this converges, it's a limit comparison test? Right, let's go for it. First thing I need to do is to do some surgery on it. Would you agree it behaves like 1 over n cubed? And 1 over n cubed is a P series. And its value is 3. And since that's greater than 1, doesn't that mean that this guy converges? So when I do the limit comparison test, I'm going to take the limit of this fella that we call AN and its comparison series, which we call BN, and I'm going to find the limit of AN over BN. And as long as it's a number that's not 0, won't I then be able to tell you that this converges as well? So I kind of know what the answer is, but now I have to prove it. So you take the AN and you divided it by the BN. So you're going to have 1 over n cubed plus 6. And on the bottom, 1 over n cubed. And then I typically take this term and change it into a multiply by reciprocal. And now I only need to find that guy. Okay, 2 ways of proving that this has a limit of 1. Give me either way of proving it. There are 2 ways to do it.
Divide by n cubed.
Right, would you agree top and bottom by n cubed gets you 1? What would be the other method?
3 happy tiles.
Right, can I just skip that bit out? You're not allowed to, but for time I can. Can we put in equals 1? Now, what do we know? We know that this converges because it's an alternating series. We proved it. We know this converges. What do we call a series, the original series, where both of these converge? We call these guys absolutely convergent. Now, can you imagine in the homework, they would have 3 circles. Absolutely convergent, conditionally convergent, or just plain old boring divergent. And in this case, that would be the guy you'd pick. And we are not going to, since I have 5 guesses, I'll pick the first one. If it doesn't work, I'll pick the second. And if it doesn't work, I pick the third and I get the answer and I move on. Because if you do that, won't you have a big problem in the midterm? Because I ain't going to bother about that part. I'm looking at this. So good habit to get into. Are we feeling a little bit more comfortable about this absolute convergent series and how we tell if a series is absolutely convergent or maybe just conditionally convergent? Let's try 15. God, the time's shot by. Okay. Now, this one is not an alternating series. So you might say, well, how do we approach, is it absolutely convergent or not, right? Well, in a way, it's a little bit easier to do because I'm just going to find out what happens to this guy. Because I know if I made it positive, it's just going to be the same, if not a little bit better. So I'm actually going to look at the positive worst case scenario for this series, right? So I'm going to look at that guy. Now I can split that. Would you agree that the absolute value of n to the 5 is just n to the 5? Now, what is the worst case scenario for 3 plus sine of n? What's the biggest, and it's a number, the biggest number in the universe that's ever going to hit?
10.
10. So wouldn't you agree that that guy is the worst case scenario for this guy? Now, if this guy converges, won't that one absolutely converge? Because this is the absolute value of it. So I'm not even going to look at the original. I'm only going to look at this guy. What do you know about this guy?
P series P equals 5.
Agreed. And because that's bigger than 1, doesn't it converge?
Yep.
So this guy is absolutely convergent. Do you see I only bother to look at what the worst case scenario is? Would you agree that anything else that could happen won't be as bad as this, so it's bound to converge? Right? If you make it the worst case scenario, you don't need to worry about the things that come later. Here's a little sneaky one in 16. And it's a bit of a cheat. It's a bit of a trick question. Cosine of n pi over 3n plus 7. And we're being asked to check what kind of convergence or divergence it has. Right? Does anybody know what the cheat is? What the kind of trick is here?
What doesn't it
It's just an
diverge?
No, it's not that.
It's just an alternating series, just with a
It
different
is.
flavor.
If you plug in cosine of n pi, don't you just get cosine pi, cosine 2 pi, cosine 3 pi, cosine 4 pi? Isn't that just a disguised version of -1 to the n? See, now that guy's dead easy, isn't he? An alternating series, and it's divergent. Sorry, it's conditionally convergent. That piece will be divergent when you make it positive. So this you'll be able to prove converges. This you will be able to prove diverges. And so the overall thing is conditionally convergent. Remember, if you get one but not the other, it's conditional. So that was the sneaky one that was going on there. Nothing happening in that one we're talking about. That's just errors again. That's error questions. Wow. Perfect question to finish with. I love these questions. I like puzzle questions. I actually think I used a question, not unlike this, in the final exam one year. And it says, for what values of P does this series converge? Not absolutely convergent, just converges, right? The usual way. And there's no proof of it. There's no, I wouldn't call it a proof anyway, but there is a way to tell.
P is greater than -1.
Yes. Tell me why.
Because if n to the 0 would be divergent, then it has to be at least to the power of 1 for it to converge.
Right, so you identified that when P is -1, this is basically 1, right? N to the 0 is 1. And would you agree that -1 to the n minus 1 over 1 is divergent? Is that what you were saying?
Yes.
Good thought. And then anything worse than that will be things like this. Because won't that come from an n to the -3? I like your thinking. That was a good way of saying it. Now, do you see that? You couldn't do it by a test. Isn't that you just look at the choices? I love that question. It's a good one.
I might be a little confused, but on that question, if P is equal to 0 from P is greater than or equal to -1,
Mm-hmm.
wouldn't that not? Oh, never mind. I'm sorry.
If you put P as -1, you get that guy, which really ends up being this guy. So I know that diverges, right? You can tell just looking. Now, if you choose anything more than that, you get an answer that looks something like this, for instance. And I know that diverges. So can you see anything that makes this power, right, 0 or negative, generates a divergent series. And that's what that is, right? Because it's P plus 1 that has to be 0 or negative. And that means P plus 1 has to be greater than or equal to.
I get it now. I'm sorry.
Yeah, okay. I got confused myself there. That's it. Put your name down, your last name, and I'll hang about for some questions. I'm getting a little puzzled if that's negative. Yeah, it is. My brain's trying to. Should I say greater than or less? I should say lesser. I think I just wrote it down right. The logic he gave me was correct. We wanted a value of P that made the bottom a negative power. And that would work if you made P less than or equal to negative. Okay, so say bye-bye. I'll hang about for questions. Bye-bye. Right, who's got a question for me?
Yeah, I just had a quick question on the direct comparison test.
Okay, what you got?
So it made sense when it was like sine, because sine can, never go below or above like
Right.
on a -1. But then it got into like natural log and E, and I was starting to have a lot of trouble figuring out like what's greater than or less than natural log, what's greater than or less than E.
Okay.
I just kind of wanted to hear your thought process on that.
Okay, could you give me one that's easier if I've got some concrete to work with?
Yeah, it should be easy to find. 1 second. Okay, it would be. Okay, yeah. So the one I have is number 18 on the thing. It was on the top, it's 1 plus 1 over n all squared. And then the bottom was e to the n.
Is it that one?
Let me look.
Or is it 1 plus 1 over n squared?
Yeah, squared. That second one. Yeah.
Okay, I'll write it neat now. So we have this guy. Right. So what I'm going to do is I'm going to say, who do you behave like? Well, when n is big, that really doesn't have a great effect. So it's basically 1.
Mm-hmm.
Which, if I write it like that, it's a geometric series with an R value of 1 over E, and 1 over E is less than 1, so I know it's going to converge.
Oh, okay, yeah, so that was the tricky one. So that was the one where you didn't have to do it.
Right, so I need to know whether it converges or diverges, because if it converges, don't I need to take this guy and prove that he's less than one of these? And if it diverged, I need to take the original and prove he's bigger than one of these, right?
Mm-hmm.
Now, since this is converging, I have this fella to start with. Then this guy, if I just removed the thing, this guy would actually be bigger than that, which is no good to me. Right?
Yeah, because it's supposed to be opposite. It's supposed to be smaller than
So
for
all
converging.
you do is you add in a multiple.
Because it's never going to get to 2.
Yeah, or if 2 doesn't work and you want to be really sure, pick 20. But eventually, would you agree that eventually 1 plus a 10th squared isn't going to be that big, right? It's definitely not going to be as big as 20.
Okay, gotcha. So you can kind of just subjectively kind of keep increasing
Yeah,
it.
if you don't feel comfortable sticking 100, 100 will catch everybody eventually, won't it?
Okay, gotcha. And then for ln is for the natural log, is it
Mhm.
just always greater than 1?
The natural log of n, it's going to be bigger than 1. It's going to get big. In fact, it'll eventually get infinite big. So you have to be a little bit careful. Can you find one with ln, and I'll show you how you would cope with that problem.
Yeah, so I have one. It's natural log of 3n divided
So-
by 5n.
So it's that guy divided by that guy. Is that what you're saying?
No natural log on the bottom.
Oh, okay. So it's got a natural log on this side and that on the bottom, right?
Yes, yes.
Yeah. Well, on the surgery side, I'm going to say it behaves like that. And the log of n takes so long to become infinite that it typically can be regarded as if it was a number, right? It's not exactly a number, but give you an example. If it was base 10, wouldn't a trillion just be 9? It wouldn't even, a trillion would be 12, right? You see that the log of a trillion is only 12, right? It's not big. Now, what that means then is that I know that this guy is a diverger, right? So I need to prove that this thing diverges. So I'm going to say that fella over 5 to the n. Now I have to figure out a diverger for him. Well, won't he be bigger than 1 over 5 to the n?
Okay, because
That's a little bit bigger than 1 if you pick n a billion, right? And if you're bigger than somebody that diverges, that's looking like a power of n, right? If you're bigger than a guy that diverges, don't you diverge?
okay, that makes sense.
Right. So I had to know whether to make it whether it was going to become a diverge or converge, because that means I need to know whether I need to make this bigger than the guy or less than the guy. Because if I don't, I could, go the wrong direction and, screw up my conclusion.
Well, yeah, because if it was like, let's say it was over n squared on the bottom, now all of a sudden.
Okay, and now all of a sudden it's converging, right?
Yeah, now what do we do with it?
Well, we know what converging does, right? Let's say it was that one. So I have to prove that this is less than or equal to somebody that converges. And I am going to pick the square root of n. Because won't the square root of n be a log?
Wait, you totally lost me.
Oh. This is the original.
Mhm.
I am going to take this guy who would have behaved like that, which is a p-series and converges. But because I've got a log here, I can't put a number because won't the log eventually be any number? So I just arbitrarily chose the square root of n.
But
Now,
you could pick like just
Cube root of
any, but you just wanted it to be less than 1 so that it would still be a converging series. Because then
correct.
for the p series, you just needed it to stay underneath that 2.
Yes. So what I've now done is I've actually compared it to that one, but that still converges. Right?
Okay, so that's why you didn't pick like n cubed or into the 4th, because then all of a sudden it would act weird.
Yeah. Now, if you got a weird one, let's suppose it was that, right? That would still converge, right? Because I'd say it behaves like 1 over n to the 1.1. That bit is just so I know what it is going to converge. But when I did my it's less than, to keep everything really kosher, wouldn't I have to pick a really small guy like that?
Yeah, so that it
To make
wouldn't,
sure
when
that
it's subtracted.
that I still got a converger out of it. Because n to the power of anything will be a log.
Gotcha.
Right.